Special cases factoring review, here we go. Gonna go a little bit faster now since this is actually the third video of this that I've done. So if you want a slower paced introduction, do the other ones. So this one I'm purposely setting up here. Also, pause the video right now and catch that. Snag it, write it down, try and do them instead of just mindlessly watching me do them. I would say for you to try and practice to do it first and then see if you got it right. Anyway, you split your x's up, opposite signs, and the ones. Basically square rooting both. You square root this one, and there you go. This one is not factorable. That says factorable. As soon as you see that this is a plus sign, you know it's not a minus sign. The signs have to be opposite. It doesn't work. That's not possible. I want you to have to know this has to be a minus sign. These have to be perfect squares for you to be able to do it, okay? So not factorable. Done. This one, same thing. Parentheses, I have my 5x and 5x. Opposite signs, because that middle term cancels out, because that end term is a negative, all those same things are why I knew this was not factorable. And 36 goes into a 6 and a 6. Cool. Here, same thing now, except I'm dealing with the exponents. Exponents are not the same as numbers. They are up here. I'm going to evenly split them apart. So my x and my x goes to a 5 and a 5. Because when I multiply these together, you add exponents, so I don't have to square root anything like I did with the actual big numbers, okay? Then I have opposite signs, and the y's are going to be split down as well, y to the 6th and y to the 6th. Cool, done, boom. It has a minus sign, it has evenly splittable stuff, cool. This one, hopefully you've tried to do this by now and have something written down, but once again, not factorable. The same thing as this one. This can be easily split up like I did, but this is 13. You cannot evenly split up 13 into two same exact chunks. I need two exactly the same pieces on both sides. I need an x to the 5th, a y to the 6th, the same thing except the signs being opposite. That's exactly what I need, and I cannot do that with a 13. One of them will be a 6, one of them would be a 7. Doesn't work. I need the exact same thing on both sides except the signs are different. That's what special cases is, okay? Cool. Getting a little bit harder now. I have a 100x to the 100th, and I'm purposely, again, trying to show the difference between the 100 goes into be a 10 and a 10, because it's the square root of 100. And then I have x and x with 50s, because I evenly split up the 100 into 50 to 50. Because 10 times 10 is 100, and x to the 50th times x to the 50th, you add exponents to be 100. Cool, done. Opposite signs, and 1 again. All right? This one I had some fun with. And I'm going to split it apart as well. The 4 goes into be a 2 and a 2. X is just x. Y is y squared. Z is z to the 3rd, right? Because I evenly split apart, x. I evenly split them all apart as they go, okay? And then I'm going to run out of room here. I'm going to have opposite signs here. I really should have expanded that. 16 goes into a 4 and a 4. A lot of people write 8 for this. It's not an 8. You're not dividing the numbers in half. You're dividing the exponents in half because they work differently. I am square rooting this to be a 4 and a 4 with opposite signs. You have your A, B, and C, but A is going to be 4, B is going to be 5, and C is going to be 6. Hopefully you can hear what I'm saying because you probably can't see what I'm writing. A, B, C is half of 8, which is 4, and then 5, and then 6. Cool. This one, they have something in common. I look at these, and you have to check for that. If you've noticed from the other ones of these, you have to look for what they have in common. So 2, factor that out. I have 50. Oops. I did nothing. I divide by 2, I get 25x squared minus 36. Oh my gosh. That's the same thing as this, but it's just been times 2. So it's twice as big as it should be. I divided by 2, and now I have the same exact thing I started with over there of the 5x plus 6 and the 5x minus 6, just like I had here at the very beginning, okay? Then this one, same thing. I have a 2 in common. They're not always going to be a 2 that they have in common, but I also have an x in common. So I factor that out. I have x squared minus 16. Divided by 2, take away an x. I divided by 2, 32 divided by 2 is 16, and then x, I take away an x, done. And then my answer is 2x. I factored that like normal. I have x plus 4 and x minus 4. Cool. And the last one, if you haven't done it yet, you should have spent just as much time on this one as you did on this one. It is not factorable. This is not even in a format that looks factorable. You should be able to know what perfect squares are. You should look for the numbers 4, 9, 16, 25, 36, 49, 8, 64, 81, all that kind of stuff, to know the perfect squares. This is 1787. They have nothing in common. They don't have any letters in common. I can't do anything. It's a plus sign in the middle. That should be another red flag. It's a plus sign in the middle. Not going to happen. Not going to think. Not factorable. You should have spent the least amount of time on this problem because it's just like, oh, it's not factorable. Okay. I'm trying to do more of those problems for that. So, wow.